Okay, welcome back, students. So today I just have prepared one final exam for you. It is actually a final exam prepared on Applied Mathematics 3 course. So I just have brought for you right now just to understand how the exam looks like. And in addition to that, you are supposed to again recall what you studied in your semester course under this applied mathematics 3. So I just have prepared this for you in order to make your study fruitful. So as usual, I just need your subscription. Let me just directly go to the final exam. As can be shown here, the final exam is given for 3 hours, and it has actually 7 pages, but I just have tried to condense it. Anyway, this is these are the exam is going to have two parts. One is instruction one part, and that is the fill in the blank part, and the other is the workout part. So in the fill in the blank part there are 10 different questions, as you see. So we are going to see how we can find the solution of these. And when you come to the workout part, you see the workout part is having actually 5 different kinds of questions from the contents of the course. So I'm going to show you again how this can also be done. So as I said earlier, your subscription is very important because I'm just preparing this for you in order to support different students. So you need to like, subscribe, and inform other students for their successfulness. Now when I directly go to the first question, it says if f of t is given by cos t sine hyperbolic t, then you are asked to find the Laplace transform of this function. So the Laplace transform of this function can be obtained as follows. As you see, the function f of t is given by cos t sine hyperbolic t. But as we know, sine hyperbolic t is defined as e to the power of t minus e to the power of negative t divided by 2. And from this, what you need to do is you have to recall shifting property. Because I'm going to take this 1 over 2 out and then take cos t with et as well as cos t with e to the power of minus t. And then I will try to apply shifting property to find the final output. So as can be shown here, look, this is 1 over 2. Now this 1 over 2 is taken out, so cos t times e to the power of t minus e to the power of minus t cos t can come. I just simply multiplied cos t for each of these two. Now what comes next is this one. So you are asked to find Laplace of this function, so have Laplace both sides, Laplace of the function f of t, and here you are having 1 over 2 and have Laplace for these two. Laplace of e to the power of t cos t minus e to the power of minus t cos t. Laplace undergo linearity property, so the Laplace of the difference of two functions is the difference of their Laplaces. Therefore, this is going to be 1 over 2 Laplace of e to the power of t cos t minus Laplace of e to the power of minus t cos t. So from the shifting property of Laplace, basically this is going to be the following one. We know that the Laplace of cos t is s over s squared plus 1, but here we are having 1 as a coefficient of t. Look, as a coefficient of t we are having 1. So using shifting property, in place of s of this Laplace transform for cos t, we're going to put s minus 1, right? S minus 1 is going to be used. Here the coefficient of t is negative 1, so in place of s of this Laplace transform cos t, which actually is s over s squared plus 1, we need to put s plus 1 because we are having here minus. So recall that the Laplace of e to the power of at times f of t is the Laplace of it is going to be the Laplace of f of a minus t. So we need to recall that one, and we will use the shifting property in order to determine the result. So from this we can have the following one. As you see, 1 over 2 comes as it is, and then look here, the Laplace of cos t is known, and that is s over 1 plus s squared, but in s you need to put s minus a, where your a is here 1 because the coefficient of t is 1, so s minus 1 is going to be used in s. Okay, it was actually s over 1 plus s squared, but now s minus 1 is used in s. The same is done here. In the case of cos t, we do have s over 1 plus s plus 1 squared, but this is s minus a. In s, we need to use s minus a. Your a is negative 1 here, so s minus minus 1 comes s plus 1. So s plus 1 over 1 plus s plus 1, the whole squared can come. So if you want to simplify, you can further simplify it, but actually the answer is going to be like this, as you see. Now going to the second question. The second question is going to be this one. You are given f of s to be like this, 6s minus 2 over s squared plus s minus 6. Now you are asked to find the Laplace inverse of f of s. Mind you that we are supposed to answer our blank space in terms of t. This is talking about Laplace inverse transform. So actually for this we need to remember the composition of this rational expression. So the solution for this goes as follows. Here it is. The Laplace inverse of f of s is the Laplace inverse of this one. What I did here is I just simply introduced Laplace inverse both sides here at the same time the right side too. Now here you need to undergo decomposition for this particular expression. So Laplace inverse of a over s plus 3 plus b over s minus 2 comes. The reason I'm having here s plus 3 and s minus 2 is I simply decomposed this. I just have taken two numbers where their sum can be positive 1, as you see, and product negative 6. Remember the factorization of quadratic expression, and I obtained the two to be 3 and minus 2. That's why I'm having here s plus 3 and s minus 2. So these two are linears, and so we need to have constants as numerators here, a and b. Now let's look for values of a and b so that you can have 6s minus 2 there. So this is going to be Laplace inverse of, look, as you are decomposing this, you are going to obtain a to be 4 and b to be 2. Basically, here students, decomposing this is very simple. What you need to do is, you see, multiple a by s minus 2 and again b by s plus 3. In doing so, you will obtain this to be a plus b times s and 3 minus 2a plus 3b. And the coefficient of s must agree with 6, it must match with 6, and the constants 3b minus 2a must match with minus 2. And so you are going to encounter systems of equations with two unknowns. So you are supposed to find these values a and b from that. So as you are doing that, you will obtain a to be 4 and b to be 2. Now Laplace inverse undergoes linearity property again. So the Laplace inverse of the sum of these two functions is nothing but it is the sum of the Laplace inverse of each of these two. So this is going to be equivalent to this one, as you see, the Laplace inverse of 4 over s plus 3 plus Laplace inverse of 2 over s minus 2. So as can be shown here, 4 can be taken out, and Laplace inverse of 1 over s plus 3 is a power of minus 3t. And the Laplace inverse of, you see, 1 over s minus 2 is a power of 2t. So 2 is taken in front, so it will be like this. So dear students, it is a Laplace of this that makes this expression the one given here. So the Laplace inverse can be obtained in such a way. Having this into account, what comes next is the question, the third question. So this again requires the second Laplace, the second shifting property of Laplace transformation. You are given a function g of t defined in a piecewise manner, as you see. For t greater than 2, you have been told that g of t is t minus 2 cubed, and for t less than 2, it is 0. So you are asked now to find the Laplace transform of g of t. Now, students, you need to recall about the Laplace second shifting property. So using that, we can find the answer for this one. So remember that in the case of this kind of definition, Laplace transform of g of t is e to the power of minus as times Laplace transform of f of t. And how is f of t noted? F of t is t cubed. You see, students, f of t is t cubed, and this t cubed is directly taken from this expression, okay? It is t minus 2 cubed. Actually, we were having t cubed, but inside t, we are having now t minus 2. So in case your function is defined this way, you see, we need to use second shifting property of Laplace transformation, and that is the Laplace transform of this function is e is a power of minus a. So what is a? A is nothing but it is 2 in the case of this, because the value that makes the expression inside the bracket 0 is 2. So your a is 2. And your f of t is t cube here, student, t cube here, because in t we are having t minus 2. So the Laplace transform of g of t is e to the power of minus ac times Laplace transform of f of t, given that f of t is t cubed. So from this directly we can add this one. Your a is, as I told you, 2, and f of t is t cubed. So from this, what comes next is Laplace transform of power function must be recalled, and that is 3 factorial. This is a power of 4 because we are having 3 here, so Laplace of t to the power of n is n factorial over s to the power of n plus 1. Since n is 3, we do have 3 factorial divided by s to the power of 4. We knew that 3 factorial is 6, so this Laplace transform is going to be 6 over s to the power of 4 times e to the power of minus 2s. So dear students, as you understand from this, you need to recall the Laplace definition as well as you see properties of Laplace in order to solve different kinds of Laplace questions, right?